Hi, I hope you all have watched my morning's video that is on dancing resonance. It's a very important topic, and if you guys haven't watched it, please do watch it. So, now we'll talk about heat of hydrogenation. This is a very simple topic, but you will find questions in many exams, be it JEE, NEET, or IIT JAM also. So, the concept should be crystal clear, okay? So, let's start. Now, the thing is, forget heat of hydrogenation. We will concentrate on hydrogenation. What is hydrogenation? So hydrogenation means when any unsaturated compound, any alkene, when it becomes saturated. Okay. So when it is done in presence of catalyst like nickel, palladium, platinum, it is called catalytic hydrogenation. Okay. Now see, I'm writing. Suppose this is an alkene. This is an alkene, right? Now, when it reacts with hydrogen in presence of nickel or palladium or platinum, okay, what will produce? The hydrogen will be attached here, okay, and it will produce RCH2 CH3. That means in this reaction, this unsaturated compound becomes what? Becomes saturated. That means the double bond is breaking. So energy will be released. Energy released. That means it is an exothermic reaction. Okay. Now the enthalpy of this reaction, of this hydrogenation, this is known as heat of hydrogenation. Okay, that means del H equals to negative. Now just keep one thing in your mind that among this nickel, palladium, platinum and platinum are highly reactive. Okay, so that's why even at room temperature this hydrogenation reaction runs smoothly, but when we use nickel, it needs high temperature to activate the catalyst. Okay, now we should keep some important points in our mind. The first one is generally the value of heat of hydrogenation, I'm writing as HOH, is minus 30 kilocalorie per mole for alkenes. Okay, so for alkenes the value is around like minus 30 kilocalorie per mole. Okay, now the next thing is the less heat of hydrogenation, that means lesser amount of energy is released, more will be the stability of alkene. Okay, so lesser the value of heat of hydrogenation, more stable double bond. Okay, suppose I'm giving you an example. Let's take this compound. This is what? This is 1 2 3 4 buta 1,3-diene, not but-1,3-diene, buta, because diene is present, double bond, two double bond, that is it's buta 1,3-diene. The value of heat of hydrogenation is around like minus 56.5 kilocalorie per mole. But for this but-2-ine, there is an alkyne, the value is minus 65.1 kilocalorie per mole. That means the value is lesser for this buta-1,3-diene. So the pi bond in this buta-1,3-diene is much stronger, is more stable pi bond, okay, than this but-2-ine. Okay, so we can conclude here that this pi bond is strong or stable. Okay, I hope it's clear, the concept is clear. Now the next thing is this heat of hydrogenation of alkene is additive. Like we can add the value unless it's conjugated. So for conjugated diene it's not additive, but for those double bonds which are not in conjugation, then we can add the value. Suppose the value of rate of hydrogenation of this compound is minus 30.3, and the value of this, these are all experimental value, it can be calculated very easily, is around like minus 60.8. Now see, it is not conjugated and it's having two double bond and here is one. So if you multiply this value into 2, approximately it becomes minus 60, right? So when the double bond is not in conjugation, then we can add the value. Now you can question, ma'am, what will happen if they are in conjugation? So if they are in conjugation, suppose in this here, so it is not these double bonds are not isolated, they are actually resonance happens na? So they are actually delocalized, there is delocalization of pi electron. So it will be like this, the double bond is over all these 4 atoms, so we can't add the value. Okay, now this is a very important third point. Now another point is, the last point is that cumulated dienes are less stable than conjugated or isolated diene. Now what does cumulated diene mean? Cumulated means nothing, there won't be any conjugation, they will be side by side, like this compound, the alene. In conjugation what happens? Pi sigma, here the 2 pi's. Here the value of heat of hydrogenation is around minus 71.3 kilocalorie per mole. But if I take this compound CH2 double bond CH double bond CH2 conjugated, then the value is around like this is the minus 56.5. Okay, that means greater is the value of this is less stable and it is more stable. So these are the points that are very important, and in the next video I'll upload some of the examples so that the total concept is clear. And if this video have helped you by any means, so just let me know and share among your friends. Bye bye, take care.